Welcome back, geometry students. We're going to start the semester off with chapter 7. This chapter is all about proportions. So if you don't remember anything else, remember proportions. So let's refresh our memory on what exactly a ratio and a proportion is. A ratio is a comparison of two quantities using division. These are the three ways you can write a ratio. I don't care which way you choose to write it, you will see it all three ways in your textbook. So you need to be familiar with all three ways. An extended ratio, if you think about the word extend, it means longer. And so that is letter C. You have more than just two ratios. You have 3 or 4 or however many different ones that you're comparing, like 3 sides of a triangle. They can all be proportional to each other or be a certain ratio. Lastly, this is the biggest concept that you should know or remember is proportion. You are going to be using those this whole chapter. So here is what a proportion looks like. It's two ratios that are equal. A is to B as C is to D. And remember, you can solve them by cross multiplying and verifying that they are equivalent. So let's move on to example 1. Let's see what we remember about ratios and proportions. You know that the number of students is 520. So that's just the number that participate in sports. That's not the whole school, because it tells you the total number is 1850. We want to find the athlete to student ratio. So we want athletes on top, students on the bottom. We know that there's 520 athletes or people that play sports out of the 1850 students that go to the school. Now, normally we would just reduce this, but you have to read directions because it tells you to find it to the nearest tenth. That should tell you to divide these. So in your calculator, figure out what 520 divided by 1850 is, and you should get about 0.281 on and on and on and on. Well, it tells you to round it, so that's going to become 0.3. That's your ratio. It's okay to have a ratio as a decimal or a fraction. You just need to pay attention to how they want it. Okay, example 2. Now, this one is probably new for you guys. No, there's no drawing, but that's okay. We know that triangle EFG, we have a ratio of the measures of the angles, 5 to 12 to 13. That does not mean that they are 5 degrees, 12 degrees, or 13 degrees, because that would not make sense. But we know that they have a ratio of 5, 12, and 13. And the perimeter is 90. Find the measures of these angles. So in this problem, we have some extra information. We're talking about angles. We need this information here, but do we care about perimeter when we're talking about angles? No, we don't care about it, so that's extra information. If you remember, triangles, the angles, what do the angles add up to? They add up to 180. So if we take our ratio, 5, 12, and 13, we're going to make an equation. 5x plus 12x plus 13x. That has to add up to the number of degrees in a triangle, which is 180. So let's simplify. Combine our x's. You will get 30x solve for x. And is that what we wanted to know? No, it tells you to find the measures of the angles. So that's where this might be new. We don't specifically know where these angles are or how big they are, but we do know that we have some information here because of their ratios. So we're just going to label angle 1, and we'll use this first one for angle 1. It's 5x. So substitute x in. It's 30 degrees. Let's find angle 2. Angle 2 is this middle piece, 12x. Let's substitute x in. Angle 2 is 72 degrees. Now angle 3, you could either add these two and subtract from 180, or you could simply say, oh, well, it's 13x, so we can solve by substituting again and just do 13 times 6 and get 78 degrees. Now, how could you check to make sure these are correct? You could add these three up and make sure that they equal 180, and they do. So turn the page. Let's try solving some proportions. See if we remember how to do that. Okay. So remember I told you you could solve a proportion by cross multiplying. So that's what we're going to do. We're going to cross multiply. 6 times y equals 18.2 times 9. Let's simplify. 6y equals 163.8. How do we solve for y? Divide by 6. Y equals 27.3. Excellent. Okay, this next one has a variable, but don't let it scare you. 6, remember to put parentheses, 4x minus 5 equals 3 times negative 26. Okay, when you're solving, don't forget to distribute the 6 to both. So 24x minus 30 equals negative 78. Let's do a little algebra. Remember your integers, 24x equals negative 48. Divide by 24. X is negative 2. It is okay to have a negative number on a proportion. Okay, last example. Hey Brooks, you're part of our problem. Okay, he surveyed 30 students. That's our total population. Only 18 of them have a dog or a cat for a pet. Now, this is just from his class, if there were 30 students. Now, what he wants to know is if he wants to survey maybe the whole school, we want to predict the number without actually surveying all 870 people. So this is not a, oh yes, this is exactly how many people. This is a prediction. So based on our ratio that 18 out of 30 people in Brooks's class have a dog or a cat, we're going to use that to find an accurate, somewhat close estimate for how many people out of the entire school have a dog or a cat. So there's our proportion. We're going to solve it just like we did in example 3. 18 times 870 equals 30x. Multiply, you will get 15,660 equals 30x, and then divide by 30. X will equal 522. What does that represent? That represents approximately how many students out of the entire school would probably have a dog or a cat. Does that mean that they will? No, but it should be very, very close. So that's lesson 7.1 on proportions. We're going to use proportions the rest of the chapter, so don't forget how to use them or set them up. See ya in lesson 7.2.